In this video, I'm going to remind you how to write an explicit equation for a geometric sequence. Now, an explicit equation is just a rule that states how to find any number in a sequence. We're talking geometric this time, so we're talking about multiplying going down our list. Well, the sequence equation for a geometric sequence looks like this. You have a sub n, which represents any value in the list, where n is the step number you're on. It's equal to the product of a sub 1, which is the first term, the value of the first term in your list, and the common ratio raised to a power. And the power it's raised to is one number less than the number that you're on. Let's take a look at an example that you would use to write an explicit equation for. So I've got an example that has four numbers in a list, 2, 6, 18, 54, and I'm asking you to write an explicit equation for that sequence. Well, to be able to do that, you're going to need the common ratio, that number that is being multiplied going down your list. Well, you also need the template as well. We'll get the template in just a minute. Let's first start with what's happening going down our list. We are growing, the sequence is growing, from a 2 to a 6 to an 18 to a 54. We know it's geometric, so that means we know that we're multiplying. So what do you multiply by 2 to get a 6? That would be a 3. What I like to do is I like to double check just to make sure, a couple of terms down, just to make sure I'm continuing to multiply by 3. 6 times 3 is 18, and 18 times 3 is 54. So I know that my common ratio is 3. Now, the equation itself looks like this, the template for the equation. A sub n is equal to the first number in the list times the common ratio raised to the n minus 1 power. Now all you're going to be substituting for this problem is your common ratio. Let's get a different color here. The common ratio, 3, is going to go in place of r, and the a sub 1 is going to be replaced by the first number in the list. And then everything else stays just like it is. So you'll write a sub n is equal to the first number in the list, 2, multiplied by, and sometimes I'll use a multiplication symbol, other times I use parentheses for multiplication. In parentheses, I'm going to write my common ratio, which is a 3. Let's back that up and use green. 3 goes in the common ratio spot, and then I raise it to the n minus 1 power. Now, don't change n minus 1. We're going to leave that as is. This is the answer. This is the equation that represents this sequence right here. Let me show you another example, and then I'll let you try one on your own. In this example, I'm going to have you do two things. First, I'm going to write my explicit equation for the sequence, but then I'm going to use the explicit equation to find the 10th term in the list. And that is the purpose for writing an explicit equation, so you can find some term down the list. Now remember, the first thing you have to do is find the common ratio. We know it's a geometric sequence, so we know we're multiplying. But you're going to look down your list and you're going to say, wait a minute, we're not multiplying because the numbers are getting smaller. And I'd say, well, wait a minute. To go from a 12 to a 3, I bet you're thinking divide by 4. It's okay to think divide by 4, but I want you writing multiplication. So dividing by 4 is the same thing as multiplying by a fourth. 1/4 of 12 is equal to 3. Likewise, if I take 3 and multiply it by a fourth, I'm going to get 3/4. And same going down the line. Every time I multiply by a fourth, I'm actually dividing by 4. So my common ratio is 1/4. Now I'm going to go grab my equation template. The explicit equation is a sub n is equal to a sub 1 times r raised to the n minus 1. I always write my template, then I fill in the values. So let me go grab my values. 12 is my first number in the list, and my common ratio is 1/4. Those are the only two things I'm going to substitute right now. So my equation should be a sub n is equal to the first number in my list, 12, 12. And then I'm multiplying, but like I said a minute ago, I like to use parentheses. And in the parentheses goes my common ratio, which is 1/4. And then that 1/4 is raised to the n minus 1 power. This is the explicit equation for that sequence. That's the first part of the problem. But then the second part of the problem is I wanted you to use that equation in order to find the 10th term in the list. Well, earlier I told y'all that, let's get a color here, I told you that the n in the sequence equation represents the term number that you're on. Well, if I want the 10th term, then I'm going to put a 10 in place of n, both there and there, because those are the two places I see an n. So here I go. A sub 10 is equal to 12 times 1/4 raised to the 10 minus 1 power. I am substituting in the 10 for the n, both there and there. Then I just simplify, and it's likely I'm going to use my calculator, so don't feel bad if you're using your calculator as well. Don't forget about order of operations though. I'm going to start by saying 12, start by hand, times 1/4 raised to the 10 minus 1 power, so that's going to be 9. Here's where I need my calculator. 1/4 raised to the 9th power. I'm not going to type in 1/4, it'd be easier to type in 0.25, so I'm going to raise 0.25 to the 9th power, get a really large number, don't be freaked out. Then after that, I'm going to multiply by 12, times 12. Now, I need to show you something. In your calculator, you are seeing 4.5776, blah, blah, blah. And then at the end, you see E, -5. I need you to understand that is your calculator's way of showing scientific notation. In other words, the human way to write it would be 4.5776. I'll take off a couple of digits. It's too many to write right now. 4.58, I'm comfortable with that, times 10 to the -5th power. That means this number is awfully small. When I multiply 12 times 1/4 to the 9th power, the answer is really, let's take a look at it this way, the answer is really 4.58 with the decimal point moved 5 places to the left. So I can either write 4.58 times 10 to the -5th power, which is totally fine, or I can write the decimal version of the answer, 0.0000458, and so on. 1, 2, 3, 4. There we go. And I need to change this equal sign to approximately equal sign because I just rounded. So the value of the 10th term in this list, as I keep dividing by 4 or multiplying by 1/4, gets awfully small. Okay, now it's your turn. Don't be freaked out if the numbers get really big or really small. Just use your calculator. Have it handy. I want you to write this sequence down on a separate sheet of paper, press pause, and then see if your work looks like mine. And this is what you should have done. We're writing an explicit equation, and then after that we're going to be using it to find the 20th term in the list. And this is not arithmetic, this is geometric. Here we go. To go from a 4 to a 20, then to 100, then to 500, it appears the numbers are getting large rather quickly, so I'm going to multiply by 5 to go down my list. That means my common ratio is 5. I'm going to use it and the first term to put it in my template. A sub 1 times r to the n minus 1, and here I go. The first term in the list is a 4. The common ratio is 5. Those are the only two numbers that get substituted. A sub 1 is a 4. The r is a 5. And the n minus 1 stays there. That is you writing an explicit equation. Then we're going to use it to find the value of the 20th term. So I'm going to take a 20 and I'm going to put a 20 in place of n there and there. Here and here. Here we go. A sub 20 is equal to 4 times 5 raised to the 20th, 20 minus 1. That's going to get really big, but pull out your calculator, you should be fine. Keep in mind, do not multiply 4 times 5 first. Order of operations declare that we have to raise numbers to a power before we multiply. Please excuse my dear Aunt Sally. P parentheses E exponents come next. So in my calculator, I'm going to multiply 5, or sorry, I'm going to raise 5 to the 19th power. Again, a really large number. Then I'll multiply by 4. Still a large number. Let's see if you got what I got. Remember, calculator says 7.629, etc. I'm going to write 7.63, and then it says E13. That's your calculator's way of showing scientific notation, which looks like this. Okay, not that. 7.63 times 10 to the 13th. Now, I really don't feel like moving my decimal place 13 spaces to the right, so I'm not going to. I'm going to write my answer as, let's see if I can get this, I can't squeeze it in. So it equals, or is approximately equal to, you know what, just write this for my answer. Alright, now what if you're asked to go backwards? In other words, what if we give you the explicit equation, this is the explicit equation, and we ask you to find the first 3 terms in the sequence and then find the 12th term after that? Well, you have to remember what the equation looks like. A sub n is equal to a sub 1 times r raised to the n minus 1 power. Knowing that, you can grab all the important pieces you need. The first number in the list is a negative 4. My list is growing by a ratio or a rate of 11. So 11 times. Each step is 11 times bigger than the one before. So I'm going to take that and I'm going to multiply each term by 11. If I multiply negative 4 times 11, I'm going to get a negative 44. So the next term in my list is a negative 44. If I multiply by 11 again, I'm going to get a negative 484. Now, since I was just asked to find the first 3 terms, that's plenty. But now, to find the 12th term in the list, I'm just going to insert 12 in place of n in my equation, and then I'm going to get my calculator to do it for me. Here I go. I'm going to type in negative 4. Well, I'm not typing that. I'm going to write it on my paper first. Negative 4 times 11 raised to the 12 minus 1 power. So in my calculator now, I'm going to say 11 raised to the 11th power, and then after that, I'm going to multiply it by a negative 4. So 11 raised to the 11th power multiplied by a negative 4 gives me a rather small number again. Negative 1.14 times 10 to the 12th. That would be the 12th term in the list. Alright, your turn. I know you've got plenty of problems to do in your homework, but might as well try this one first and then you'll know you have it. So here we go. You're being asked to write an explicit equation for that geometric sequence and then generate the first 3 terms and then find the 25th term. I said write an equation. You're not asked to write the equation, you're using the equation. So here's the equation that I'm using. From that equation, I know that the first term in the list is 18. I know my common ratio is 1/3, and I'm raising it to the n minus 1 power. So hopefully you paused, have worked it out, and you're looking back at this answer now. The first number is 18. The next number is 1/3 as big as 18. That's the same thing as dividing by 3. I'm going to do this one in my head. 18 divided by 3 is 6. 6 divided by 3 is 2. 2 divided by 3 is 2/3, but I only had to get the first 3 terms, so good enough right there. To find the 25th term in the list, All I'm going to do is insert 25 in place of n. N stands for the term number. So the 25th term in the list comes from taking 18, multiplying it by a third, raised to the 25 minus 1 power, raised to the 24th power. So in your calculator, this is interesting, and this is actually, I'm glad I put this problem here because this is a mistake that a lot of students use. A lot of students do. Please don't type in don't type in 0.3 for a third. In your calculator, please type in 1 divided by 3, because if you type in 0.3, you are already already reducing the problem. You really should never reduce within a problem. You should wait till the end to simplify. I keep saying reduce and simplify. Round is the word I'm looking for. So type in your calculator 1 divided by 3. In parentheses, 1 divided by 3. The reason I have to put it in parentheses is because I'm raising 1/3 to the 24th power. So 1/3 in parentheses, raised to the 24th power, T9C, and then I multiply it by 18. Again, still T9C. My answer is 6.37 times 10 to the negative 11th power. This would be the 12th term in the list. These are the first 3 terms of the sequence. This is the 12th term of the sequence. Tiny. Remember, we were dividing by 3 the entire time. So, a quick recap. The purpose of the explicit equation is to help you find any number in the sequence, and that's what we did when we found the 25th number or the 10th number or the 12th number in the list. It's most important that you guys memorize these equations. Now, this right here is the sequence format for an explicit equation, a sub n. This over here is the function format, but I just have to remind you that not all sequences are functions, so don't be surprised if you see function notation or function format versus sequence format. They both have the equal representation. What I mean by that is the a sub n and the f of n stand for any number in the list, any number in the list. The a sub 1, the f of 1 stand for the first number in the list. And then the r raised to the n minus 1 power is the same for both equations. It's the common ratio raised to the number that's one step back of the one you're on. So hopefully you now know about writing explicit equations for geometric sequences. Good luck!